Hello everyone, I'm Jacopo Fior, a PhD student here at Politecnico under the supervision of Professor Luca Cagliera, and my research work concerns knowledge discovery from financial data. Specifically, my main research interests concern the field of data-driven trading and portfolio management. This field is not new by any means, but it's quickly expanding in the latest years, mostly thanks to the improvement of the related technologies and, most important, the increase of available data and their complexity. Quantitative trading is divided into two complementary approaches, differentiated by the end purpose: the forecasting of an asset price or direction, and the portfolio optimization and asset management. Let's start from the forecasting approach. Its end purpose is trading in the most common meaning of the word, buying and selling assets and commodities try to time the market in order to make a profit. The time horizon is quite short, being it a fast-paced activity. There are numerous data-driven approaches to the problem employing different technologies. Generalizing, usually shallow approaches are used in order to predict the price or price direction of a single asset in a short-term scenario, while deep learning approaches tend to include data from multiple assets and perform usually better when the amount of data available is big enough. The second approach to quantitative trading has a different goal, selecting the assets to include in a portfolio in order to maximize long-term profits. Most of the works in this category are based on the model portfolio theory introduced by Markowitz in 1952. The goal is to maximize the expected return for a given level of risk. Generally, when testing portfolio management strategies, a buy and hold strategy is employed as a baseline. Having introduced the two main directions of the field, I want to present my contributions to it. I worked, and I'm still working, on both those topics. Moreover, given the time series nature of financial data, I've also employed the knowledge and expertise gathered in the financial domain to other fields that employ similar formatted data, such as vehicular data and weather data. Having little time, I present only my main research works. Let me start by presenting my works concerning the short-term trading topic. First of all, I worked at a system that combines machine learning-based trading recommendations with candlestick pattern-based ones. After finding the best agreement strategies between the two classes of trading signals, we obtained great results, and the work is currently undergoing the final stages of journal publication. Another work I worked on in the short-term scenario concerned the selection of the best data granularity for price forecasting. Our findings reflect the fact that both extremely fine and extremely coarse data granularities negatively affect the results of the system, while the best results are obtained by data granularity in the ballpark of 1 measurement every 30 to 120 minutes. And finally, concerning the short-term scenario, I'm working on a system tailored for cryptocurrencies, exploiting specific features found in a blockchain. This is quite interesting, since different cryptos are based on different technologies and so are affected by different features of the blockchain. Concerning instead the long-term investment topic, my work has been focused on improving a state-of-the-art item set-based portfolio selection tool. One of the most important aspects of long-term investing is the diversification of the assets. The industry standard is to diversify stocks based on the market sectors on which company operates, and this is also what was done by the original system. Instead, I included the clustering steps using cross-correlation to diversify the portfolio based on database similarities and dissimilarities between stocks, obtaining actually promising results. Another improvement over the original system was to incorporate a multi-objective optimization step